All right, hi guys. These are the notes for section 1.3, and this is part 1 notes. We're going to split it into two. Today we're going to be talking about equivalent equations. We're going to talk about solving one-step equations, which you did last year, and combining like terms, which you also did last year. We'll also do some distributive property. So first we're going to talk about equivalent equations. And these are equations that have the same solution or solutions. So what I'll ask you to do is to determine whether two equations are equivalent equations. So let's do a really quick example of that. So an example will say something like this. Determine whether, and then it'll give you two or more equations. 4x equals 12 and 10x equals 30 are equivalent equations. So we're going to decide if these have the same solution or solutions. All right, so if we look at our first one, 4x equals 12, we can see here that the only thing that'll work for x would be the number 3, right? Because 4 times 3 is 12. So on this one, we know x is 3. Almost wrote 12 there. And our second equation, 10x equals 30, well, we know that 10 times 3 is 30. So in this case, x has to be 3. I don't think there's anything else that'll work. So in this case, we would answer yes, these are equivalent equations. I think you guys will be able to figure that out pretty easily. It's more just knowing the vocab word in this case, equivalent equations. So now we're going to move into solving one-step equations. We worked a lot on this last year at the end of the year. So hopefully you'll remember we drew a lot of yellow dotted lines, or I drew them yellow, at least on the board. So we're going to start right now with solving one-step equations. And we're just going to do this in examples. So here's our first example. We're going to solve. We're going to start off, hopefully this seems easy since we did it last year. X plus 7 equals 10. So right now we're wondering to ourselves what plus 7 is 10. All right, and I know that right now you're like, okay, well, I already know what number plus 7 is 10. But let's say you didn't. Here's what you would do if you were down to one more step left. You only have one step. There's only one operation happening to this x. Draw a line through your equal sign. You want to look at your variable, and you're trying to get him all by himself. Remember talking about this last year? This variable, he likes to be home alone. He does not like anyone else at his house. We got to get everyone away. So we got to get everyone onto the other side of that line. So we need to move this plus 7. So you need to think of what's the opposite operation of adding 7. What would undo that? So the answer in this case is subtracting 7. So right under that, I want you to write minus 7 and minus 7 on both sides. Whatever you do to one side, you have to do it to the other side. That's how we kind of move it over. So then you can think to yourself, okay, what do I have left here? I like to draw a line to show like I'm kind of adding up what I have. Well, positive 7 minus 7, that's 0, and x plus 0 is just x. So those go away. We're left with x here. And on the other side of our line, which is where our equal sign always stays, is 10 minus 7, which is 3. Now you can check your solution here. I know that you already know this one's right, but you can plug it back into this equation. 3 plus 7 is 10. So we know we were right. X is 3. That's it. Hopefully, I hope you remember that from last year. All right, so let's do another example here. This time I'm going to do a subtracting example. So let's do, we're going to solve y minus 4 equals 1.1. So we're wanting to, when it says solve, it means tell me what this y equals. So we're looking for this y. We need to get him all by himself on his side of the equal sign. He does not like anyone else to be there. Okay, he doesn't want anyone else there in his house with him. So to get rid of the -4, you need to think of the opposite operation. So we're going to add 4 to each side. Draw a line so you can figure out what you have left. -4 plus 4 on this side, well, that's 0. So we're just left with y, because y plus 0 is just y. So y equals 1.1 plus 4. So we have 5.1. Now, if on your paper, if you have a line going through your equal sign like I do right now, I really like you to rewrite your answer so that you don't have a line there. So I'm going to rewrite it so it's nice and neat here. Y equals 5.1. And you can plug that in. 5.1 minus 4, and that is 1.1. So we know we were right. Y equals 5.1. So that was addition and subtraction. Let's do a multiplication example, a division example, and then a fraction example, and then I'll give you a few to try on your own. All right, so here is our multiplication example. So we are going to solve 3x equals 18. Solve means we want this variable's value. We want to know, what does x have to be? 3 times what is 18? I hope you already know the answer, but let's say you didn't. We need to undo this 3 being multiplied to the x, because that x does not like that 3 being there. So to undo that, well, the inverse operation of multiplying is dividing. So we like to do the division with this line, kind of like a fraction, and not the division sign like that. We don't want to use that in this case. This just keeps it a little neater if we do it this way. So remember, if we divide by 3 on one side, whatever you do to one side, you have to do it to the other side of your equation. So we're going to divide by 3 on both sides. This works because over here, 3 divided by 3 is 1, and 1x is just x. 1 times x is just x. So I'm left with x equals 18 divided by 3, which is 6. I'm going to rewrite my answer to make it neat with no line through it. And you can plug it back in. 3 times x, so 3 times 6, and it is 18. So I know my answer worked. That was multiplication. Let's try a division problem. So I've got z divided by 4 equals 2.3. So this could look like this kind of division. It could look like this over here, and you would solve it the same way. Whoops. So we're going to get this z by itself. He does not want that 4 there. So to undo the z being divided by 4, we have to do the inverse operation, and we're going to multiply by 4. I want to make sure and write that my 4 is multiplied up here. Okay, you don't want to write the 4 in this spot right here, because that's a 4 in the denominator. That's like 1/4. We don't want that. We're multiplying by 4 over 1. Okay, because 4 over 1 times 1/4, or 4 over 4, is 1. And that's what we wanted here. All right, so over here, we are multiplying, I'm going to put this in parentheses, by 4. I was afraid a dot for multiplication would look like that decimal. So we're multiplying by 4 on both sides to get that z by itself. So I'm left with z equals 2.3 times 4. So if you weren't sure, remember you can always set up multiplication like this if you need to. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. And you've got one spot to move your decimal. So 9.2. And if you try 9.2 and divide it by 4, it should be 2.3. So z is 9.2. All right, we've got a fraction one to do, and then I will give you a couple examples to try. All right, so we're going to try 3/4 x equals 5/7. So this is saying 3/4 times x equals 5/7. Make sure when you wrote this 3/4 x, you could write it like this, 3x over 4, or you could write it like I wrote it, 3 over 4x. You cannot write it 3 over 4x. This x is in the denominator, and that means that that x has a negative exponent, and we do not want that right now. So do not write your x on the denominator. All right, so to get this x by itself now, we need to do something to both sides of the equation. Well, you can kind of think about this sort of as a two-step equation. Right now, this x, there's a 4 in the denominator. We know we need a 4 in the numerator to get rid of that. So we have to multiply by 4 on both sides to get rid of the 4 in the denominator. We also have this 3 in the numerator next to x, and we don't want that, so we need a 3 in the denominator. That'll go away. Just like we talked about the other day, the law of reciprocals, it says that 3/4 times its reciprocal, 4/3 right here, is 1. So perfect. Now we have 1x, which is just x. Just make sure, since we're multiplying by 4/3 here, we have to multiply by 4/3 there. So we are left with x equals whatever we get here. So 5 times 4 is 20, and 7 times 3 is 21. So 20, 21st. I'm going to rewrite my answer so it's neater here. X is 20 over 21. Make sure you check if any fractions can be simplified. All right, I'm going to give you guys 3 examples that I'd like you to try for homework on this next page, a B, and a C. A is -4/5 y equals 1/2. B is x minus 11 equals 100. And C is y over 4 equals -11. So go ahead and pause the video, try those 3, and then I'm going to talk about combining like terms. All right, so we're going to talk about combining like terms. Hopefully you remember some of this from last year. So first I want to talk about what a term is. Remember from last year, I really like the word term because it's really important in algebra. So a term is a part of an expression that is added or subtracted. So I'm going to write an example of a polynomial here. That's an equation with more than one term. I'm going to write 3x squared plus 4y minus 7. This polynomial right here has 3 terms. The 3x squared, the 4y, and the -7. That negative is really important. So if I was going to list all the terms here, I would say they are 3x squared, 4y, and -7. Those are my 3 terms. Now, what's important when we're talking about combining like terms is what like terms are. So like terms are terms with the exact same that says exact, sorry, looks bad. Terms with the exact same variable part. So they have to have the same letters on them, basically. So some examples of things that would be like terms, well, a simple example would be like 3x and 2x. They each have an x, so those are like terms. A little bit more complicated example would be something like 3x squared y and 7x squared y. Those are like terms. They have the exact same letters. The x's are squared in both of them, and they have a y. All right? So they have to have the exact same variable part. So if things are like terms, you can add them up. That's the important thing here. So I'm going to give you an example, and I'm going to say that you need to combine your like terms, or the instructions might say simplify. All right. So as an example, we're going to simplify this expression. 3a plus 5a squared minus 7a plus a squared. So you want to look for which of these terms, and there are 1, 2, 3, 4 terms here, which ones have the exact same variable parts. So if I look up for something to match up with this 3a, I know that everything has some kind of a, but the only thing with just a plain old a is this negative 7a. So we can add those up. So 3a plus negative 7a, or you can think of it as 3a minus 7a, that is negative 4a. Remember, when you're adding or subtracting terms, just add or subtract the numbers, the coefficients, and keep the letter exactly the same. Don't change it. So this is negative 4a. And then 5a squared and a squared, which, if you don't see a coefficient, it is 1. Always remember that. If you don't see a coefficient, it's 1. So this is 1a squared. If we add 5a squareds and 1a squared, well, altogether we have 6a squared. And since they're positive, we put a plus sign in between, and that is a simplified form of our equation. Negative 4a plus 6a squared. Later on, we'll technically write that in a different order, but for now, that's okay. So I want you guys to try an example of this. I'm going to put it on the next page. That says try. I want you guys to try 6x minus 7 minus x minus 9. So I want you to try to simplify that, and we will check it tomorrow. All right. I'm getting a little long here, but I want to try at least one more here. So I want to try using the distributive law to combine like terms. So this one, the instructions again would just be simplify 6x plus 4 times x minus 12. All right. So here, we kind of have to think about order of operations if we're going to simplify this. We can't combine the 6x and the x right now because this is technically not x. It's an x, but it's being multiplied by this 4 because we have to distribute this 4. Remember, we learned about the distributive property. So what we need to do first is distribute. So we're going to distribute 4 times x is 4x. And then we're going to do 4 times negative 12, and that is negative 48. So we're going to write negative 48 there. Now don't forget this 6x sitting out in front. So we still have 6x plus all of that. So now that we distributed, we can combine like terms. So we need to combine 6x and 4x. That's 10x if we add those up. And this negative 48, unfortunately, sorry, he doesn't have anyone to combine with. So he's got to just stay on the end by himself, but that's it, 10x minus 48. So I'm going to give you one example like this. I was going to do more, but I'm afraid it'll be too long. So just remind me tomorrow this is where we stopped, and we'll do the rest of the notes in class. They're pretty short. 2 more examples and 2 more for you to try. So here's one more I want you to try. So I want you to try to simplify this. 3y minus 3 times 6 plus y. All right, try simplifying that. That's your last one. Remind me of where we left off, and we will check this in class tomorrow. Thanks for watching. Bye.